Okay, this video, last class we simplified radicals and now we are just going to do operations with them. Now, when we do these, we're only going to be dealing with square roots. We're not going to deal with third, fourth, fifth, sixth roots. All right, so the first thing we're going to do is multiply radicals. And you can multiply anything you want. When it comes to radicals, you can multiply the numbers that are in the radical or both out, but we don't really mix and match them. So on this one, 21 and 15 are both inside the radical, so we can multiply them, and we get the square root of 315. So we successfully combined it into one, but now we have to simplify that radical. Well, we can put all sorts of numbers in, but we know we just used 21 and 15, so we know that has to work. This is 3 and 5. This is 7 and 3. So when I simplify this, we get 3 square root. 7 and 5 go in, because remember, when we're doing this, we're only looking at the numbers at the end of our factor tree, ignoring anything else. And anything that's a pair goes outside. Anything that's not paired up gets multiplied inside. So this gives me 3 square root 35. And that is my answer. Okay, let's try this again on number 2. This time we have numbers both inside and outside of our radical. So we can multiply the outside ones and we can multiply the inside ones, but we're not going to mix and match. So outside we have 3 and 2, so that's going to be 6. Inside we have 20 times 18, which will give us 360. Now we need to simplify 360. Well, let's just start with 20 and 18. This is 2 and 9. Oops. Going too fast. 2 and 9 and 3 and 3. This is 4 and 5 and 2 and 2. Okay, now when we go to rewrite this 6 that was already outside, it has to remain outside. Then each pair represents one number outside. Hold on, I'll use a different color. The radical. If we should have more than one number outside the radical, they all get multiplied together. Anything that is a prime number and doesn't get paired up, it goes back underneath. And so when I simplify this, 6 times 2 is 12, times 3 is 36. So I end up with 36 square root 10. So it's just like simplifying the square root, except you got to remember that 6 is already outside. We are just going to add things to it. Okay, let's try number 3 and repeat this process. So on this one, numbers outside, 5 times 4 would be 20. Inside we have 6 times 10, which would be 60. So 60 is 6 and 10, 2 and 5, 3 and 2. So this 20 is already outside. It stays outside. This pair comes outside. And anything that's at the end of the factor tree and is not paired up goes underneath. And that leaves us with 40 square root 15. Okay, the next thing we're going to do is square these radicals. And because inside the parentheses I have a monomial, meaning I don't have any pluses or minuses, I can just distribute this exponent. So this is really 5 squared times the square root of 7 squared. Now, off to the side, let's talk about what it means to be the square root of 7 squared. Well, if we square it, that means we need to multiply it by itself. So that's the square root of 7 times the square root of 7. Well, since they're both inside the radical, we can multiply them. So this is the square root of 49, which is just 7. So when you square a radical, it cancels it and you get the number underneath. So 5 squared is 25, but the square root of 7 squared is just 7. And you don't add these together. That's the most common mistake. You multiply these together. So we get 175 for our final answer. Okay, let's do this again. On number 5, okay, my cat is walking on the screen, which does not help. Sorry about that. Okay, on number 5, we need to square each one. So this is 2 squared times the square root of 6 squared. 2 squared is 4. When you square a radical, it cancels it and you get the number underneath. So this is 4 times 6, which is 24. Okay, one more time on the next one. And the reality is that we don't have to write all this work out. 3 squared is 9. Square root of 2 squared is 2. 9 times 2 is 18. Done. All right, let's look at these. Now we are going to add and subtract radicals. And when we add and subtract, we can only add and subtract if they are like terms. And for a radical to be a like term, we have to have the same number inside of the radical. So over here, here's 2 square root 7 and negative square root 7. Those match because they both have a radical 7. So we're just going to subtract the numbers out front. 2 minus 7 is negative 5. So I have negative 5 square root 7. This 3 square root 6 didn't have anything that matched with it, so I can't combine it to anything else. So this is just plus 3 square root 6. Over here on number 2, both of these are like terms because they're radical 3. Now this first one, when there's no number there, there's an invisible 1. There's one of them, right? Because if it was 0 of them, they wouldn't be there. So it's 1 minus 5, so I get negative 4 square root 3. Okay, now this works great if my radicals are simplified, but if the radicals are not simplified, this is not going to work. And so we need to simplify them first. So 45 is really 9 times 5, which is 3 times 3. So 45 is really 3 square root 5 plus 20. 20 is 4 times 5 and 2 times 2. So it's really 2 square root 5. Now they match. Now they're like terms. So now I can just add them together. 3 plus 2 is 5. So I get 5 square root 5. You do not change what's under the radical. You just simply combine them together. They're like terms. Just like when you add 3x and 2x, you don't change the x's. You just get 5x. Same idea, but now it's radicals instead of x's. Okay, over here, 50. 50 would be 2 square root, 2 and 25, 5 and 5. Now be careful. This 6 is already outside. The 5 comes outside and the 2 is underneath. So the first one is 30 square root 2 minus this one over here. This is 2 and 16, 4 and 4. This 2 is already outside. This 4 can now come outside, and this 2 is left over, leaving me with 8 square root 2. So 30 square root 2 minus 8 square root 2 is going to be 22 square root 2. Since they both have radical 2's, we can subtract them. And remember, we don't change the radical. We just add and subtract the numbers in front. Okay, let's try this again on number 5. So on number 5, first, we need to simplify the 12. Well, that's 3 and 4 and 2 and 2. Now remember, the 6 is out front, the 2 comes out front, and then we have the 3. So this is 12 square root 3 minus 27. It's 3 and 9, 3 and 3. So the 4 is already outside. The 3 comes out, and there's a 3 underneath. So I have 12 square root 3. Over here, 8, 2 and 4, 2 and 2. This 4 is already outside. This 2 gets to come outside. This 2 over here is left over and it goes underneath, and we get plus 8 square root 2. Now, these first 2 are the only ones that are like terms because they're the only ones that have radicals that match. And 12 minus 12 gives me 0. They just cancel out. So all that is left is 8 square root 2 because it doesn't combine with anything. All right. Now we're going to do a little bit of multiplying binomials. Okay, so we're going to FOIL or distribute just like you would if there was x's, but now the numbers are just going to be a little bit different. Okay, over here, first thing we are going to multiply is the square root of 5 times the square root of 5. So remember, off to the side, let's think. Square root of 5 times square root of 5 is square root of 25, and the square root of 5 is just 5. So it's like you're squaring it. It is squaring it. Okay, so this is going to be 5. Then over here, I get square root 5 times 6, so that's plus 6 square root 5. Over here, I get minus 6 square root 5. And then negative 6 times 6 is plus 36. Now I'm going to combine like terms. 5 and 36 is 41. And 6 square root 5 and negative 6 square root 5, those just cancel out. So my final answer of all that is just 41. All right, let's see what happens on the next one. So now I'm going to take 2 square root 3 times the square root of 3. So let's think about this. I have 2 square root 3 times the square root of 3. That's like what we started with in the beginning. You can multiply them if they're both in the radical or both out. So the only thing that's out is 2. The only thing that's inside is 3 times 3, which is 9. And the square root of 9 is 3. So this is just 2 times 3, which is 6. So we're going to have 6. Then over here, this gives me negative 2 square root 3. Then I multiply here and I get 5 square root 3. Then over here, I get negative 5. Let's combine like terms. 6 and negative 5 is 1. Negative 2 and 5 would be 3 square root 3. And we're done. Okay, let's try this again. Square root 2 times 7. Well, that's going to be 7 times the square root of 4. And the square root of 4 is 2. So that's going to be 7 times 2. If you want to write that as 14, you are welcome to. Square root of 2 times 1 is 1 square root 2. Negative 3 times 7 square root 2 is negative 21 square root 2. Over here, we get negative 3. Now, before I combine like terms, if you haven't done it already, 7 times 2 is 14. Now I can combine like terms. 14 and negative 3 would be 11. Square root 2 and negative 21. Well, remember, there's an invisible 1 here, so negative 21 and positive 1 would add to 20 square root 2. And that's my final answer. Okay, the last thing that we are going to do is take a fractional exponent and write it as radicals, because in the coming days, we are going to be working with exponents that are fractional. And then when we get done, we're going to write our final answer as a radical. So all we want to do now, we are not solving anything. We are just simply writing it in different form. So it's like someone asking you how old you are, and instead of responding with, I'm 17, you respond with 7 plus 10. It is still the same answer. You are just writing it in a different form. So we're not solving anything. We are just writing it in a different form. Okay, so how do we do this? Well, we are going to start with a radical. Whatever the base is, that's still going to be our base over here. Whatever the denominator is, that is going to go on the shelf. And then whatever the numerator is, that is going to be my exponent, which is 1. Now, anything to the first power, we do not need to write that. So this is really just the cube root of x. Okay, let's try this again. Over here, the base is 8. That goes under the radical. The denominator goes on the shelf, and the numerator is the exponent. But we don't need to write to the first power, so this is just the 5th root of 8. All right, let's try it again. The base, 112, goes under the radical. The 3 goes on the shelf, and the 2 is the exponent. Remember, we are not trying to get an answer. We are simply writing it in a different form so we are prepared to do what we need next class. This one, the y goes under the radical. The 5 goes on the shelf. The 4 is the exponent. On the next one, the 50 goes under. The 2 goes on the shelf, and the 1 is the exponent. But let's think about that. When we have a 2, we don't write it. It's understood, so we don't need to. And we have an exponent of 1, we don't need to write it. So now we know anything to the 1/2 power is the same as the square root. Let's write that out so we can remember. Whoops, I can't spell any. Try this again. Anything to the 1/2 power is the same as taking the square root. Okay? So that means anything to the 1/3 power is the same as taking the cube root, and anything to the 1/4 power is the same as taking the 4th root. And we could go on and on and on, but this fact is very, very, very important. Okay, next one, 42 goes under the radical. 5 goes on the shelf. 3 is the exponent. Over here, z goes under the radical. 2 on the shelf. 3 is the exponent. On the last one, 25 goes underneath, 5 is on the shelf, 2 is the exponent. Now, next week, we'll do stuff with these. Right now, we just need to know how to rewrite it. Okay, so now that you've finished the notes, you now need to complete the homework. And when you're done with the homework, you're going to turn in both the notes and the homework to the sub.